Definitions, formal definitions, are an everyday occurrence during your mathematical journey. And because of their everyday occurrence, because of their frequency, it's worth noting a very kind of subtle fact about definitions. And again, because of the frequency that definitions show up over the course of your journey through mathematics, it's really, really important that we note down this fact because it can sometimes be tricky. And you'll see why in a little bit why it can kind of be tricky. So definitions are statements that make two things equivalent. Definitions are statements that make two things equivalent. Make two things equivalent. So, for example, if I say definition, and I say we define A, whatever A is, it could be a statement, say, we define A to be B. What this really means is that A and B are equivalent. But what does this word equivalent mean? Well, equivalent, or two things are equivalent if, or let me avoid defining equivalence since we're defining definition here. But I'll say if A is equivalent to B, then that means that if A holds true, then that implies that B holds true. And if B holds true, then that implies that A holds true. That is to say, A if and only if B. When I say two things are equivalent, then that means that those two things, or rather, when I say two things are equivalent, that's the same as saying that one thing holds if and only if the other thing holds. So a statement of equivalence is the same as a statement as an if and only if statement. So that's really important. That means that definitions, instead of using this definition for definitions, we can say the following. Definitions are statements, are if and only if, sometimes abbreviated like this, are if and only if statements. Now, you might have noticed throughout your journey through mathematics that you might have come across definitions, and in fact most definitions drop the and only if part. So you might see a definition like this. A function, so if they're defining continuity, for instance, a function is continuous if yada yada yada, these certain properties hold, whatever these properties are over here. But what they really mean is a function is continuous if and only if these properties hold. But the and only if part is implied, or it's dropped. They don't include it. So what this means is if a function is continuous, then that implies that these properties hold. And if these properties hold, then that implies that a function is continuous. So let's go to our example up here. If quadrupeds are defined as animals having four legs, it will follow that animals having four legs are quadrupeds, a little quote from Bertrand Russell. So what the two things that he's making equivalent here are quadrupeds and animals having four legs. So what he's saying here is that if you're an animal that's a quadruped, then that implies that you're also an animal that has four legs. And then also, if you're an animal that has four legs, then that implies that you're a quadruped. That is to say that these two things are equivalent. So now we have sort of, in the meta, we have defined what a definition is.